Hello everyone. Now we are starting the next concepts of network layer protocols. The first concept is network address. The network address is an address that defines the network itself. It cannot be assigned to the host. A network address is also known as numerical network part of an IP address. This is used to distinguish a network that has its own host and address. For example, the IP address 192.168.1.0. In this IP, the network address is 192.168. Next is address mask or default mask. An address mask determines which portion of an IP address identifies the network and which portion identifies the host. Like the IP address, the mask is represented by 4 octets. An octet is an 8-bit binary number equivalent to decimal number in the range of 0 to 255. If the given bit mask is 1, then corresponding bit IP address in the network portion of the address, and if the given bit of the mask is 0, then the corresponding bit of the IP address is in the host portion. For example, consider a class C address 28.16. In this, 192.15.28 correspond to the network part and 16 correspond to the host part, as we studied in the previous videos. So as differentiate the network and host part, we have to use the mask 255.255.255.0. This mask in the both decimal format and in binary format assigned with the class C address of IP address 192.15.28.16. If a field of network address is entirely used for the network, the corresponding field of the mask has the decimal value 255, that is binary 8 times 1. And if the address field is entirely for the host ID, then the corresponding field of the mask has the decimal value 0. Accordingly, the address mask for 3 network class describes the if 255 is their number, then binary value will be 8 times 8, and if the decimal value in the field of mask is 0, then 8 times 0 will be there. That identifies the host ID if the 0 is there, or if the 255 is there, it identifies the network number. Which IP protocol version is being used currently? So the network protocol of the internet is currently used is IPv4, and it was first introduced into 1970s. After that, the world of data communication has grown beyond the imagination, even though IPv4 is well designed protocol and it has some limitations. As we see limitations, first we have to know the concept of the special IP addresses. All zeros means the host of these networks are, and all one means the broadcast address to the all host indicates the network. As I told you previously, the if all zeros are there means 8 times zeros are there, the number is in host part. If all ones are there, that means 8 times ones are there, then the network will be in the network part. The IP address 0.0.0 is used by the host when they are being booted but not used afterwards. The IP address with the 0 as the network number refers to the own network without knowing its number. The address having all ones used for the broadcasting on the local networks such as LAN. This is an address with proper network number and all ones in the host field. This address allows a machine to send a broadcast packet to the distant LAN anywhere in the internet. If the address is 127 point next is anything, then it is reserved address for the loopback testing, and the feature is also used for the debugging of network softwares. Now we are going towards your limitations of IPv4. The most obvious limitation of IPv4 is the address field. The IP relies on network layer address to identify the endpoint on network, and each network device has a unique IP address. The IPv4 uses a 32-bit addressing scheme which gives in the 4 billion possible addresses. With the proliferate of network devices, including PCs, cell phone, wireless devices. Unique IP addresses are becoming scarce, and the world could theoretically run out of the IP address. If the network has a slightly more number of hosts than the particular class, then it needs either two IP address that can class or the next class of the IP address. For example, let us use the network has 300 hosts. Then the network needs either a single class B IP address or the two class C IP addresses. If the B addresses are allocated to this network as the number of the hosts that can be defined in the class B network is 2 raised to 16 minus 2, a large number of host IP addresses are vested. If the two class C IP addresses are allocated, then the number of the networks can define by using a class C address only 2 raised to 21. So the number of available class C network will you quickly exhausted because the above two reasons. A lot of IP addresses are vested and also available for IP's address space rapidly reducing. Other identified limitations are or IPv4 protocols are complex host and router configuration, non-hierarchy addressing, difficulty in renumbering of address, large routing tables, non-trivial implementation in providing security, quality of the service is the major issue. Mobility and multi-homing and multicasting is also an issue with the IPv4. To overcome these problems, Internet Protocol version 6, that is your IPv6, which is also known as Internet Protocol Next Generation IPNG, was proposed. In IPv6, the Internet Protocol was extensively modified for accommodation of foreseen growth of the Internet. The format and length of IP address has been changed and packet format is also changed in the IPv6. Next point is subnetting in IP. All the hosts in the network must be the same network number, but this property of an IP address can be problematic as the network size increased. For example, a company initially may have only one LAN, but at the time passes, it might end up with many LANs, each one having its own router and each one with its own class C network number. With increase in the number of distinct local network, their management becomes a problem. Every time a new network gets installed, the system administrator has to contact the NIC to get a new network number, and then this number is to be announced to worldwide. Another problem is that if a machine is to be moved from one LAN to the other, then its IP address needs to be changed. This will require the modification in the configurational file, and its modified IP address needs to be announced worldwide. The solution of this problem is the network is split into the several smaller networks internally, but it acts like a single network outside the world. The smaller part of the network is called as a subnet. Now continue with the same example taken at the beginning of this subsection. The growing company should start up with the class B address instead of class C, and then the number of hosts from the 1 to 254. When a second LAN is to be installed, it can be split into the 16-bit host number into the 6-bit subnet number and 10-bit host number. Means in the host part is going to split into the subnet identifier as well as host identifier. Due to this split possible to connect 62 LANs, 0 and 1s are reserved because each one is containing up to 1022 hosts. Outside this network, the subnetting is not visible. So even if the new subnet is created, it is not necessary to contact with NIC or chain and anything else in the network. Next is subnet mask. The number of ones in the subnet mask is more than the number of ones in the corresponding default mask. If the subnet mask, we change the some leftmost 0 into default mask to make a subnet mask. For example, class B network is there, and suppose the IP is 255.255.0.0, then first 16-bit will keep as it is. Then in the host part, all zeros are there. In that all zeros, first 3 bits of ones are first 3 bits of zeros are replaced by the 3 bits of 1. So there are 3 extra ones. Instead of 10, we have 13 bits of 0 and 16 bits of 1. The number of subnets, the number of subnet is determined by the number of extra ones. For 3 extra number ones, subnet will be 2 raised to 3 because we have added 3 extra ones. So 2 raised to 3 is equal to 8. For n extra ones in the number of subnet is 2 raised to n. Next is classless addressing. Even though numbers of actual devices connected to the internet is much less than 4 billion, address depletion has taken place due to the flaws in the classful addressing scheme. We have to run out the class A and class B address. To overcome this problem, the classless addressing is now being tried out. In this classless addressing, there are no classes, but addresses are address generation taking place in the blocks. Address blocks is defined as the range of the addresses. In the classless addressing, when an entity wants to get connected to the internet, a block or the range of the address is granted to it. The size of this block, that is number of addresses, dependent upon the size of the entity as well as its nature. This means for a small entity such as household, only 1 or 2 addresses will be given, whereas the large entity like organization, thousands of addresses can be allotted to that particular area. Next are restrictions of classless addressing. Sir, some of restriction of the classless addressing blocks have been imposed by the Internet Authority in order to simplify the process of addressing handling. The address in the block should be continuous, that is in the serial manner. The total number of the address in the blocks has been equivalent to the power of 2, that is 2 raised to 1, 2 raised to 2, 2 raised to 3, etc. The first address should be evenly divisible by the number of addresses. Okay, the classless class full addressing system based on the classes, and it is also classless addressing is based on the it is used to improve the IP addressing scheme, and it is based on the block system, and it is also known as the classless interdomain routing, that is your CIDR. Next is supernetting. Class A and class B addresses are almost depleted, but the class C addresses are still available. But the size of the class C addresses with the maximum number of 256 addresses does not satisfy the need of the organization. More addresses will be required for that. The solution is supernetting. In the supernetting, an organization combines several class C blocks to create a large range of addresses. That is, several networks are combined to create a supernetwork. By doing this, an organization can apply a set of class C blocks instead of just ones. Example of supernetting is, if suppose the organization needs 1,000 addresses, they can be obtained by using class C block. One C class block correspond to 256 blocks. The organization can then use these addresses as the super network as a whole. Next is options in IPv4 datagram header. Before going to options, you must know the who decides that IP addresses. Now, 2 IP addresses should be same. This is ensured by the central authority that issues the prefix or the network number portion of the IP addresses. Locally, an ISP is to be contacted in order to get a unique IP address prefix. At the global level, the Internet Assigned Numbering Authority, that is IANA, allotted an IP address prefix to the ISP. Thus, the ensures that the IP addresses are not duplicated. Conceptually, IANA is the wholesale and the ISP is the retailer of the IP address, because the ISP purchased the IP address from the IANA and sells them to the customer. Registered and unregistered addresses are also there. So registered IP addresses are required for computers for which accessible from the internet, but not every computer that is connected to the internet. All are not registered addresses. For security reasons, network use firewalls or some other technologies for protecting the computers. The firewall will enable the workstation to access the internet, but do not allow the other system on the internet to access them. These workstations are given an unregistered private IP addresses. These addresses are assigned by the network administrator without obtaining them from the ISP. ISP is the Internet Service Provider or the IANA. These are special network addresses in each class. These addresses are to be used for private networks called as a unregistered address. We can choose any of them unregistered address while building our own private network. That class A is 10.0.0.0 through 10.255.255.255. For class B, that is 172.16.0.0 through 172.31.255.255, and for class C 192.168.0.0 through 192.168.255.255. These are unregistered address, and we can use these addresses for building our private networks. So next part is options in IPv4 datagram header. There are two parts. First is a fixed part and second is a variable part. Fixed part is the single byte options, and second variable is the multiple byte options. In the single byte options, there is two operations: no operation and end of operation. And in multiple byte options, there are four options. First is record route, strict source route, loose source route, and timestamp. So first is no operation. This is one byte option which is used for the filter between the options. End of operation, this is also one byte option which is used for the padding at the end of the option field. It can only use at the as the last option. Next is record route. These are multi-bytes options. This no operation and end of operations have only one byte operations. Next is record route. This is multiple byte option is used for recording the internet router which handles the datagram. It can prepare a list of up to 9 addresses of such routers. These options may be used for debugging and management. Next option is strict source route. This multiple byte option is used for the source for predefining a route for the datagram. This is called as a dictation of the route by the source. Next is loose source route. This multiple byte option is similar to the strict source route, but it is less rigid. It is necessary for the datagram to visit all the routers in the given list, but the datagram is allowed to visit other routers as well, which are not in the list. Next is timestamp. This is multiple byte option is used for the recording the time of datagram processing by the router. This time is measured from the midnight universal time, that is Greenwich time, and it is expressed in the milliseconds. Thank you.